Hello everyone, in this video we are trying to learn about the image visualization in Earth Engine. All the codes used in this video are from this site. This is the guide from the Earth Engine. So to begin with, we have a few codes here. So in the Earth Engine, the very important one is Map.addLayer. Map.addLayer in the Earth Engine is used to visualize the image. Using this, the first three bands are assigned as red, green, and blue, and the strays each done based on the type of data. And we have different image visualization parameters. We have minimum and maximum values. We have gain and vice values, gamma, palettes for the colors, opacity for the transparency, and the format for JPG or PNG. So in this code in particular, we have loaded the image. This is the unique ID of the image. There are different ways to retrieve this. And here we have the ee.image, and these whole codes are being loaded into this variable image. And here we have the visualization parameters. Here we have the bands, band 5, band 4, and band 3, minimum and maximum values, and gamma. And we have set the center somewhere at this location. And this has been added as a layer. The first one is the image. The second one is the visualization parameters. We have written here a V's with capital PARAMS. This whole lines could have been feature, just a way to include by the variable name. And the last one here inside the single quote is the name of the layer. And when we run this, we get false color. It is something reddish brownish color type of image. And there are certainly different types of visualization that could be done. And it is a typical method for the visualization. So this code here is the very standard way. We see it everywhere, done in the Earth Engine, and this is the way the image has been layered with the false color. And for the single band of image in color, we can also use palettes. Palettes, for example, here we have used palettes, and palette parameters uses CSS style color string. They are the hexadecimal value of the colors, and they are unique values that is used for different colors. So here we have the image loaded again. This is the same image from the previous one, and we have here image.normalize difference. This is the function to calculate or generate the NDWI or NDVI. It doesn't matter, but the formula is similar for different indices. So the normalized difference uses the two bands, and they calculate it from the two bands here. And we have here minimum and maximum values. We have palettes with two different colors, and that has been added as the layer. And here we want to mask those layers where NDWI is greater than 0.4. This is done by image.update mask, and image.update mask sets the opacity of the pixels. The pixels equal to 0 are excluded from the computations, and the opacity is set to 0 for display. So this is what is going in this codes. So when we run this, and also we have here false in the Map.addLayer, So by default, this won't be loaded, or this won't be ticked here for the in the layer. So we have to check this to appear. So this is the NDII. We have calculated from the normalized difference. We have the visualization parameter, and this is for the single band. And the previous one was with the 3 bands, but here we have this done only for the single band, and this is the NDII. And there are different visualization parameters that may be used with the different minimum and maximum values. And in the new layer, at the very top, we have the NDII masked. So here we want to have only those layers which is not the water. So here we have only the waters highlighted. However, the other areas, or the land, is not actually colored. So this is what is meant by masking, when using those pixels that are used and separating them, which are not to be used for any computation. So this was the first and the second examples. So here in the third example, here we have the image.visualize, and image.visualize converts image into an 8-bit RGB image for a display or export. In this example, we convert the false color composite that was done earlier. I believe that was image RGB. Selecting the bands. Here we select the bands, and the maximum values here we have 0.5. And similarly, we have the NDII masked. So yes, NDII masked, this is the variable from earlier here, NDII masked, and we are visualizing with minimum and maximum values, and we have the palettes. So we are converting the false color composite and NDII image to 3-band display image. Similarly, we have the mosaic queue, and we do this by image collection.mosaic, and it helps for the various cartographic effects. The mosaic, here we have the mosaic. It renders layers in the output image according to the order, first one and second one here, and it combines the two layers, and we have the new visualization. That is exactly what is being done here. So if we see here we have the two different layers kind of stacked, and it appears the same. There could have been other ways as well by layering, but here in the single layer it appears. And the next one is dot clip. Dot clip is something that clips that area, and we are here clipping the mosaic created earlier. And for that, we are creating our region of interest in a point, and the buffer zone here, the buffer zone has been created by dot buffer, and some distance from that point. And when we run this, get something like this here. So here we have something like this. This is something appears as circle, and we have just clicked the previous mosaic, and it appears very nicely. Only those layer, only these certain areas have been visualized. So there are other maps as well. For example, there is land cover maps, and for land cover maps, we have discrete values, and for that discrete valued maps, we use the palettes, and for each category, we provide the different colors, and this can be added as the here. So here we see 18 categories for the land cover classes, and each category has the unique value or unique color. So here it appears something like this, with different colors, different categories. And there is another ways to do that as well. There is something called styled layer description, and it appears something as HTML, if you are aware of. And this SLD is something something as the extension of web map service. It helps the users for the user-defined colors and symbols for geographic features. And there are certain things what ArtEngine can do with SLDs. So here is the particular example. We have the Morris image, Morris land cover map, and we are using SLD for certain intervals, every unique intervals. Here we have a unique color for each of them. Inside this symbols, we have color map entry, we have the color, certain quantity, and we have levels. So when we run this, the result is actually similar to the previous one, but it's the flexibility that ArtEngine provides to us. It's the result is same actually. So if we see here, it actually is same. And we have the same result, but with different ways. And the important thing is this SLD is provided with image.sld style. And here we have the variable assigned earlier. And the next one is similar to this one. Here we are doing with a similar way. This is the visualizing for ramp and interval types. And this is for the DEM. So here we can see for certain intervals. Here we have the quantities. Quantities, and this appears something very brighter. So actually, this is just a way how this styled layer descriptor can be used in ArtEngine. These are the typical examples here. So similar to the previous one, we have here image.sld style and the variables name here. And these are doing with the outside this one. This is the inside this curly bracket. We could have used the visualizing parameters that we discussed, that we saw earlier. But other than that, the SLD is directly applied to the image by .sld style. So it's not the visualizing parameters we are using inside the curly bracket. That's outside of that one. And there is another example here. So in this example, we have the stretching of the pixel values for improving the visualization of the continuous data. So here we have the band 5, band 4, and band 3 bands. And here we have the enhance here. This enhance is replaced every time with histogram and normalized. The things are the same, but only this has been changed. This is the probably the efficient way to do it. So the code here compares the result with the minimum and maximum normalization with histogram equalization. So same code, same set of codes or same set of SLDs is used, but differently. And only the value is replaced. And after that, we have the edit normal STS linear. And here we have displayed the result with the different stretching of the pixels. So if we see here, this one is the linear. This we see we are using by default. Inside here we have the bands, and the other two ones, the other two are from the image.sld style by equalized and normalized. So it's works very differently. It's the stretching of the pixels. And the last example is related with the thumbnails. So for thumbnail images, we have ee.image.get thumb URL, and it generates the image that might be in PNG or JPEG format. It results in a URL. So here we have the image, and for that image, we have the get thumb URL. We are doing some masking and some minimum. We are providing some minimum, maximum dimensions, and by this get thumb URL, we will get the unique URL that will generate the thumbnail. So here we have the first thumbnail, and similarly, we have also used palettes. We have a region, and this is the second thumbnail. And the third thumbnail here we have the we have set some web marketer system here. This is just the projection system. So 3 different thumbnail. If we run them again, we now get something in the console, the unique link from where we can download them. So if we open link in new tab here, so this is it. This is the thumbnail images we are getting, and we can set them just like any other images. So this was all about the image visualization. There are certainly the ways how it's being done, not just using the visualization parameters. We also have the SLD style that can be used, and all things also helps us to get the advantage of the thumbnail image. Here we have the very nicely created thumbnails that can be set like any other image. And also we also learned something about the line cover maps. We are visualizing them. Of course, the instruction or the guides have so many detailed explanation However, in this video, we tried to interpret in our own ways. So I hope this was helpful to you. Any comments are welcomed. So thank you. Thank you for watching this. Thank you.